Hello, my name is Mike Knight. Today we're going to be working on another combination circuit, one that you pretty much have to redraw pretty well. It'd be really difficult to see it, especially as a new person starting out, to see what's series and what's parallel. So we're going to redraw this one. So first I'm going to draw what it looks like, and then we're going to redraw it something that we can easily work with. So here we go. So it looks like got a resistor, and then it's got a resistor, it comes down here, it's got a resistor out here, and then from the middle of these, let's see, this one here, and from the middle of these two, it's got a resistor coming down, a resistor coming down, and a resistor in the middle, and this comes out to here, and then this one comes down like that. Alright, and it looks like they've got them labeled. Looks like they got this one R7, R1, R6, R3, R5, R2, R4. Okay, so that's kind of how they have them labeled there. So let's see what we can do with this. So this would come around that, and that would be our power supply. Power supply right there, be a battery or whatever. Alright, so let's redraw it first. And then I'll put the values on here. So when I'm coming along, and I could go either direction, it really doesn't matter which way you go. But I'm just going to come across here and do that first series, because it's by itself before that node. Alright, and then I've got a piece of wire here, and it's going from the output. This is R7. I'm going to go ahead and put what it is. And then I've got this wire going 1, 2, 3 places. So I'm going to come out here, and I'm going to go, the last place over here would be R6. So I'm going to put that right like this. R6. Okay, and then R5, and then R4, is right there. So the output of 7, and some people put like minus and plus, minus and plus, minus and plus, minus and plus. So if that technique works better for you, helps you understand it a little better, that's fine too. But I've got output of 7 to input of 6, 5, and 4. And that's usually how I think about it, inputs and outputs. But minus and positive would be the same thing. Okay, so from R6 goes to, and this would be minus and plus, minus and plus. R6 goes to the output of 5. So that means these two are hooked together, right? It also goes to the input of 3 and 2. So R6 goes to the input of 3 and 2. And I could do it like this if I wanted. That would help it make a little more sense. R3. R2, something like that. All right, and then let's see, the output of 3 and 2 and 4 all hooked together. So that would be like this, right? The output of 4, all the positives are going to hook together, 4, 2, and 3. Okay, and then there's an R1 after that. So I could put it down here, or I could just do it like this. R1 would be another way I could do it. And this here we go to my power supply. And I'll just leave it open because I usually put all my numbers in there. All right, so that looks like what we have right there. By getting the rest of our numbers on here, 30 volts for E2. All right, 10 ohms for R3. E4 is 60 volts. I5 is 2 amps. All right, and R6 is 15 ohms. R7 is 1 ohm. Let's see, I think that's it. Let's see, got something on everything, right? Okay, so where to start on this? Generally, I'll start, somewhere in there probably. The easiest thing to get here is this is a parallel branch, and it's got 30 volts on that side, so it has to have 30 volts on this side. So then, once you get two things, you can solve that problem, right? So we have two things here we can solve. So E divided by R equals I, so that would be 3 amps. 30 divided by 10 is 3. And then P is equal to E times I, which 30 times 3 is 90 watts. All right, that's good. Let's see, what else can we get? Let's see here. All right, we have 60 volts there. So that means we've got 60 volts here. So that means this whole branch sees 60 volts, and I've got 30 there, so this would be 30. And if that's 30, that means this has to be 30. Because this branch drops 60 volts. So that means this whole branch has to drop 60 volts, each path. So that's 30 and 30, 60. That's 30 and 30, 60, 30, 30, 60, 30, and 30, 60. No matter which path you go, it's going to drop to 60 volts, same as that one. So that's good. All right, so we can solve all these. So E divided by R equals I, so that would be 2 amps. 30 divided by 15. And 30 times 2 for power would be 60 watts. 30 divided by 2 would be 15. Whoops, I got this wrong. I got those in the wrong places all. Let's move 2 amps. Put the 2 amps up here. Be better. And that would be the 15 ohms. And then that would be the 60 watts. No problem. All right, so if I have 2 amps here and 2 amps here, that means I have 4 here. I've got 3 there. That leaves 1 for here. Because 2 amps go together, so this is 4 amps. It splits back apart. 3 goes that way, 1 goes that way. So 30 divided by 1 for R would be 30 ohms. 30 times 1 would be 30 watts. That should be easy enough. All right, what can we get next? Oh, let's see, we've got one thing missing here. We're supposed to have 1 ohm here. All right, so we could solve this one. I forgot to put that 1 ohm on there. That was a given, so that's why I circle these to make sure I have all the given numbers. So 1 ohm, 10 divided by 1 equals 10 amps. 10 volts divided by 1 equals 10 amps. 10 amps times 10 amps equals 100 watts. All right, so we solved that one. Now let's see, what else can we get? So we know if this is 10 amps, and this total over here was 4, right? 3 and 1, so that's 4 coming out of this path. So I've got 4 amps coming from this way. I've got 10 total. That means I have to have 6 amps coming from this way. 4 and 6 equal 10. So that means I have to have 6 amps right here. All right, and 60 divided by 6 will give me 10 ohms. And 6 times 6, we'll use a calculator. I could figure that, but 6 times 60 equals 360 watts. Sometimes it's better to use a calculator just to make sure you don't mess up. So if this is 10 amps, this is in series, I've got 10 amps going through here, then all this adds together up here. I have to have the same amount here, 10 amps. 10 amps. So that would be 10 volts, and that would be 100 watts, the same as the one down below. So that's easy enough. Okay, so now remember, each path has to drop all the voltage, so I've got 60, 70, 80 volts for my total. 80 volts, not very good there. Let's do it a little bit bigger, 80 volts. I've got 10 amps going through this series, so that's what the total has to be, is 10 amps. And now RT, I could do that. The easy way to do that is volts divided by amps equals resistance, right? So 80 divided by 10 equals 8 ohms. 8 ohms. And then power would be 800 watts, volts times amps. So that's 800 watts. So now let's check ourselves here. Let's just put it in the calculator. We have 100 watts plus 360 watts plus 60 plus 60 plus 90 plus 30 plus 100 . So let's see, 120, 120, 240, 6, 7, 8. So that should come out right. 800, and we could do it the other way. We take 800 minus 100 minus 100 minus 360 minus 60 minus 60 minus 30 minus 90 equals 0. So they subtract out. Check our current. We have 10 amps. So we have 10 amps here in the series part. 10 amps here. It splits up. 6 goes this way, and 4 goes this way. It splits up. 2 and 2, 3 and 1, back to 4. 4 and 6 is 10. So that's good. Our resistance. Now our resistance is a little trickier, so we'll do that just so sometimes you have to figure it out, everything out by resistance. So when we do resistance, we collapse it to make it like one series circuit, and then we expand it back out to to solve everything. So let's just do the resistance here. So these two are in parallel, so that's going to be reciprocal. So we'll do 10 ohms reciprocal plus 30 reciprocal equals reciprocal equals. And so this branch right here is the equivalent of 7.5 ohms. It will always be less than the smallest resistor in a parallel branch. So this half of the branch is 7.5 ohms. Now this half of the branch will do 15 reciprocal plus 50, oops, plus, you can hit the delete key there to back up. 15 reciprocal equals. Now if these are the same resistance, you could just take 15 divided by 2. And it would be 7.5, right? The same as that one, actually. So let's hit that equals. Reciprocal equals 7.5. So this is 7.5 ohms, and this is 7.5 ohms. So we add those together. That would be the equivalent of this. 7.5 and 7.5. So we add those two together, and that would be the equivalent of 15 ohms. So these will equal 15 ohms. That's this branch here is 15 ohms. And this one's 10 ohms. So let's go back. We'll do 15 reciprocal plus 10 reciprocal equals 6 ohms. So this whole thing, this whole part here is 6 ohms. So I'm just going to do it like this, 6 ohms. So then this would appear to be just a series circuit now, and you just add them all together, right? So 6, 7, 8, and 8 ohms was our answer originally, so that's right. So that's how you solve it with just resistance. You have to collapse everything down until you end up with just like a series circuit, like right here. You get your resistance, and then you get your current and your voltage, everything over here, and you start expanding it back out. And I'll probably do one like that a little bit later on.